So far we have learned 4 ways to show that 2 triangles are congruent to each other. We've learned that if we match all 3 sides of one to all 3 sides of another, that works. We call that side, 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 or SSS. We learned that if we match 2 sides and the angle that's between those, that's a side angle side, and that will work. We learned that if we have a right triangle and we can match the hypotenuse in a leg, that will work. Or if we have a right triangle and we can match both sets of legs, that will work. Today we're going to learn 2 more ways. There will be 8 ways in total. So today we'll learn 2 and then tomorrow we'll learn our last 2 ways. Today's ways are very similar, so we have to be careful about what we're doing here in our pictures. Today, for both of the ways, we will know 2 angles and 1 side. The difference comes in the placement of that side. So our 2 ways today are going to be angle, side angle, or angle, angle, side. One of these is technically a postulate, and one of them is a theorem, which means one we just have to accept, and the other one we could prove, but we're not going to actually prove the theorem itself. We'll just prove things using the theorem. But pictures will probably be helpful to you here, because these 2 ways are very similar. Both of them use 2 angles and a side. The important difference is the placement of that side. So if I have 2 angles, and I have the side that is included, or the side that connects those angles to each other, that is an angle, side angle. If I have 2 angles in the side that connects those 2 angles together, that is angle, side angle. Okay? So in these I've got this angle, and the side that's connecting them. That is angle, side angle. The other option is that I have 2 angles, and the side that I have is not the connector. So I've got 2 angles and some other side. That is angle, angle, side. Both of these ways use 2 angles and 1 side, and the important difference comes in the placement of that side. Is it the side that's connecting the 2 angles together, or is it some other side of the triangle?
So the bottom would be AAS.
Okay. The bottom and that other one would also be an angle, angle, side. Yep. Okay. So we determine the difference by looking at the side that we have and seeing if it's connecting the 2 angles that we know, or if it's one of the other 2 sides. So we're going to start with our given. Which is 2 sets of angles. So we've got the 2 sets of angles with B as their vertex. And we've got the 2 angles with X as their vertex. Now notice it just says those 2 angles are congruent. It doesn't say that they're right angles. Technically they would have to be because they're congruent and they make up a straight line, which is 180. But since we're not actually using the words right angles in this problem, we're not going to use one of our right angle reasons. Okay, we're just saying that they're congruent. So we've got 2 things marked in our picture. So we need to know a third thing. What else can I know about these 2 triangles?
Bx is equal to Bx. Congruent.
Bx is congruent to Bx by reflexive. And the way we can know that is that that side is in both of the triangles. It's what they share. And the way we can know that we keep the letters the same way instead of like a BXXB is because this is a folding. If I fold close those 2 triangles, they'll land on top of each other. So I'll mark that side as being the same now. That's 3 things marked in the triangle, so that should be sufficient to say that these are congruent. So I can say triangle ABX is congruent to triangle CBX. In them, I have 2 angles and 1 side marked. So now we have to determine which one of these ways is it. Is it the side that connects the angles, or is it some other side? Is it the connecting side, or is it a different side?
ASA.
It's the connecting side, because if I mark my angles and the side, It all connects together. Two angles on the side that connects. So this would be an ASA. An angle, then directly aside, and then an angle with nothing happening between them. Okay. Questions? Our second example is much the same. We're going to use the same picture, and again, we're given two sets of angles. So marking these up in our picture, again, we're given both angles at B, and this time we're given the angle at A matches the angle at C. Two things marked in the triangles. We have to know three things to be able to say that they're congruent to each other. So what's a third thing I can know about these triangles? Same thing as the last time. So when we first start proofs, I'll have a lot of students who say, like, I'm really struggling with proofs, and like, how can I get better? What can I do to get myself better? And sadly, the answer really is just do more proofs. In algebra, I can give students like a first step you do this, second step you do this, third step you do this, and sometimes students can have no clue what they're really doing and still be able to solve a problem just because they learn how to follow steps. Proofs, we can't really do that because they're all kind of different. I can't give you a step by step by step, but the more you do, the more they really start to look the same. That we're doing a lot of the same things over and over. We're doing this reflective thing a lot in these problems. And you'll start to notice the more that we do, we're doing the same types of things kind of over and over and over. So the best way to get better at proofs is just to keep on practicing proofs and look for those similarities. So when I mark up that side, that's three things marked in the triangle, so now I should be able to say the triangles are congruent. The three things that are marked are two angles in one side, so we have to decide, is it the side that connects the angles, or is it some other side? So what are we going to have here? Angle, angle, side. It's not the connecting side. Which one would I have to know if I was going to use ASA? Yeah, I would have to know that BC and BA are congruent because that's the side that connects the angles that are drawn in the picture. So if I knew that one, it would be an ASA, but since I know a different one, it's an AAS. For those of you who may be like me and struggle with some slight dyslexia issues, or maybe even not so slight, just got to be really careful because we're using a lot of the same things with sides and angles. So we had SSS, SAS, AAS, ASA, and then even with drawing out these angles, we're using the same letters over and over, and the order of the letters matters. So if you find that you struggle with that, you just really have to make sure that you're focusing carefully on that because order does matter with a lot of the things here.
Are these ones gonna like all be 3 steps?
They will not necessarily all be 3 steps, probably 3 or 4, maybe at most a 5. The homework tonight comes from worksheet G. So last night the homework came from F. G is right next to that, so you're going to be looking on the next column over for the problems for tonight's assignment.